Okay, so we have now discussed what matter and dark matter are. So matter makes up only 4% of the universe. So when you think about atoms, atoms have a electrical shell surrounding the nucleus. The nucleus has the protons and neutrons in it. Inside the protons and neutrons are quarks. So when you look around the room, you're looking at matter. Then we talked about what dark matter is, and dark matter doesn't interact with light so that it appears to be dark, but it does have mass, so it does cause gravity. And we talked about some possible candidates for what dark matter is. So that still leaves us with 73% of the universe. That's what dark energy is going to be. Dark energy is going to have properties of being anti-gravity. Gravity tries to pull everything in. Dark energy tries to push everything out. So that's what dark energy does. So evidence for dark energy is found by looking through our telescopes into outer space and looking at galaxy clusters. So if you have a balloon and you put some dots on it, then those dots would represent clusters of galaxies. Now let's circle one of them and pretend that's where the Earth is. Now we're going to blow up the balloon so that the balloon is bigger, and we're going to still put those same 4 clusters of galaxies, and we'll still circle this one, and we're going to measure the distance from here to here, here to here, here to here. And then we measure the distance from here to here, here to here, here to here, and we notice it's bigger. So the universe is expanding, space and time are expanding, and they are carrying with them these clusters of galaxies. And so it appears that the Earth is the center of the universe, but it's not. Because if you pick any of these and circle them, you get the same effect. So all the clusters of galaxies are moving away from all the clusters of galaxies. And now one reason for this expansion of space and time is the Big Bang. So when that happened, it's like setting off a hand grenade, and it sends out a shock wave that expands. So the space and time expanded as a result of the Big Bang. But it's not the whole picture, though. Because if it was just the Big Bang, the universe would be slowing down as it expands. But it's not. The universe is actually speeding up in its expansion, is accelerating. So if I take this pen and I let it go, it accelerates. It goes faster and faster down because of gravity. But imagine that I take the pen and I let it go and it shoots up into the air, going faster and faster. So you would say that's caused by anti-gravity. Well, in the expansion of the universe, the expansion is going faster and faster, caused by dark energy. Okay, now what is dark energy? So we really don't have much of a clue as to what it is. But here are 2 possible theories. We said that permeating our universe and surrounding our universe is this virtual energy, the energy vacuum. And so that energy from the energy vacuum can manifest itself in our universe as matter and antimatter that appear and then go back together again, disappear, and go back into the energy vacuum. There are some people that think that in certain spots in our universe, there is a rip in the space-time, and so you have this virtual energy pouring into our universe from the energy vacuum. And maybe that's what's powering the expansion of space and time. Another possibility is the formula for gravity. So the classical formula, the Newtonian formula for gravity, which is minus big G, and then mass number 1 mass number 2, and then divided by r squared. Notice that the formula has a negative sign on it. That tells you that the force of gravity always pulls inward. Now imagine, though, that that was not the entire story. Maybe there is another term that needs to be added to this. And so it's going to be F, some kind of a force that we don't know about, but it does depend on distance r. And it has a positive term. So this one's negative, and then this one's positive. So as r gets bigger and bigger, so we're talking about cosmic distances here. As this r gets bigger, so does this term. And eventually this term becomes bigger than this term over here. So that gravity at very, very large distances, instead of being attractive, turns to being repulsive. Now, this is not the correct way of thinking about gravity. Remember, general relativity is the correct way of viewing the universe. So later, in a future lesson, we're going to talk about the general relativity, and I'll show you the formula for general relativity, and it will turn out it has two parts to it. It has a negative part, and then it has a positive part to it. And so in terms of general relativity, that also can be used to explain dark energy, but we'll talk about that later. So I'd like for you to take a look at this little video here on what is dark matter and what is dark energy on YouTube, and that should help to explain this a little bit better. Okay, so now we have explained what matter is. So in our next segment, we're going to start talking about what are the fundamental forces that control the universe.